I'm Amber Brown. I'm also known as Hawk Owl. That's the alias I've gone through for the past couple of years. I live in Perth, Western Australia, and here's one of our great council buildings. It's where all the government goes. And it's basically like Perth. It doesn't look very good. It's like the rest of it. I don't like my home city. I organise Django Girls events. So this here is a picture of Perth Web Girls 2014. 2015, at the start of 2015. Perth Web Girls is a combination of Rouse Girls and Django Girls. And it's been rather successful. We've had 2 so far. And we're planning another one. So yeah, a couple of people show up to it. Don't think anyone important does. I do serve on the Django Code of Conduct Committee, but I am a Twisted core developer and release manager, and 15.5, the 6th release of 2015, which is the most we've ever had in 1 year, is coming out pretty soon. It's going to be exciting. So this is basically Twisted, you know, just yes, flag, we're all cubes. We're squares, you see. So I work for Crossbar.io, which is a company that makes a WebSocket router. They also make Audemars, which is another thing for Twisted that does WebSockets. So the talk that was given at DjangoCon Australia in 2014 has sort of changed how I give talks since then. And this wasn't me, this was someone else. But it's sort of shaped how I want to speak at places. Now, as I'm an invited speaker, it's expected that I have something to tell you. It's only worthwhile if I tell you something and educate you something, or at least be funny in the process. So I'm going to say this with no ambiguity at all. This talk's conclusion is not that Django sucks. Far from it. It's not that using Twisted makes you a better programmer. I think that the conclusion is that Python web development will end up best when we both work together. And if you have another conclusion from this, you're quite frankly wrong. So they're both pretty good. So this talk is full of spiders. I go pretty deep dive into Twisted. So no question is stupid. It's something that I know and a lot of other people don't. So if I go over something and I don't explain it well, that's because I haven't thought to explain that. It's a little bit hard telling people all these things that you sort of expect they already know because you already know them. So I want to be wary of that. So for the concepts. For the purposes of this talk, synchronous code returns in line, like this. So it's a function and it returns. Asynchronous code calls another function with a result at some later time. So here is an asynchronous function. So it doesn't return. It can return immediately. The function that can happen before it returns, but it's just that it doesn't happen at the same time. However, with some new fancy things in Python, this is also asynchronous. It's just a bit of syntactic sugar. So they don't return immediately. Python actually suspends at the yield point and it does some other things. It's purely syntactic sugar. And blocking, for the purposes of this talk, means that Python cannot run anything else during that period due to I/O operations. Short CPU-bound tasks, like iterating over a list, are not considered blocking. But long CPU-bound operations, such as going over a large data set, or short or long I/O bound operations are blocking. Short I/O takes a long time. Now, if you ping something like Google, it's like 30 milliseconds. That's quick. You can't blink that fast. But that's forever in a computer time. 30 milliseconds, if you have one CPU cycle as 1 second, then doing a ping out to Google is 400 years. You don't want to sit around for 400 years waiting for something in the mail. You want to do other things while you're waiting for that. So what is Twisted? It's an asynchronous networking framework. So we have a whole bunch of things that help us do it. It's at least a decade old. It's from the first commit in the SVN repository, which was once a CVS repository, which was once probably a text file somewhere on some server. It's 14 years old. It's very stable and very mature. We have a very strong compatibility policy. We have many protocol implementations: HTTP, SMTP, IMAP, DNS, SSH. Soon we'll have HTTP2. We have like MSN that isn't even run anymore. Thanks to deprecation policy, it's still deprecated. We can't remove it, even though all the servers have shut down. Double-edged sword. We have Python 2.7 and 3.3 plus support. The Python 3 port is incomplete. It's about 50% there. We've got all the bases. It's just a lot of protocols, and we'll get there eventually. The porting is just going through it, getting all the string literals, adding B at the start of them, compiling, see if it works. We have time-based versioning. So 15.0 is the first release, in 2015. 15.5 is the 6th release. So the first one in 2016 will be 16.0. So we're not quite as bad as Chrome, but you know. How Twisted's React works. Now this is the spiders. Sockets usually block until the data is sent. And Twisted configures the sockets to be non-blocking. So given the non-blocking socket.write will write to the send buffer and return immediately. It won't actually wait for the data to be sent over the wire. If the send buffer is full, it raises an exception, or if the enum E would block, as in the send buffer is full and it can't do anything but wait for it to send the existing data before it can keep adding things to its own buffer. Twisted has a secondary write buffer that is held in user space. When you call socket.write, it puts in a kernel space buffer. I'm 90% sure. Probably differs on the implementation. The secondary send buffering is taken care of by the protocol class. Now, everything in Twisted is a protocol. And because we've got this abstraction, we can do this in the background and you never call socket.write. If you call socket.write, you're violating some abstractions pretty badly. Next. Yes. Socket.read is also automatically called by protocol. So you don't actually read from it. Twisted just tells you when things have been read. So Twisted's reactor alerts protocol when there is more data to be read or more data can be written. So how it does this is select poll, epoll, or KQ, or a couple others. These are system calls. So these system calls take a list of file descriptors, like a socket, but it can also be other things like writing to a file or writing to standard in, standard out, that sort of thing, and returns the ones that have when they can have further data written or read. So if you have, say, 1, 2, 3, 4, 5, 6, and they're all send sockets, and they've all filled up their buffers, and then number 6 gets sent, it'll return 6, because you can now write more to it. If more data can be written, protocols tries to empty its secondary send buffer. And if more data can be read, protocol reads it, gives it to user code with an overridden data received method that every protocol implements, and then you'll just do it again. So it's always waiting for data to arrive. This handles the base sending and receiving of data, but we always operate on a higher level. We don't want to deal with that sort of lower things. We use protocols which implement something, like WebSockets or SMTP, HTTP, anything you can imagine. Basically anything that has a connection and has some sort of state, even if it's, well, okay, doesn't have to have state, but if it's a connection, a protocol will be made for that connection, so it manages that specific connection. Protocols are asynchronous. They deal with asynchronous I/O. So the consumption of the data must also be asynchronous. So to use this, we use something called deferreds. Now, I'm going to be a bit angry for a second. If you follow me on Twitter, you probably know how angry I can get. I get pretty angry. I'm Australian, it's natural. So, what? Well, not everything's trying to kill me. It's like, just anger. So, you might have heard this before. If you don't understand deferreds, you're too stupid for Twisted. That belief has no place in any Twisted I'm a part of. I've been a release manager now for 2 years, and I'm taking a lead on the project, doing a lot of things, the Python 3 porting, release management, core stuff. I'm also a Twisted fellow. And as a leader in the community, we have to stand up against this sort of thing because it has historically been a problem. And we should no longer accept just walking past it because, as Russell has said before, from a quote from one of our army leaders, the standard you walk past is the standard you accept. So it has happened before, and we can't always fix everything done in the past, but I will say going forward, or for quite a while now, that is no longer acceptable in the Twisted community. So if you don't get deferreds, it's our failure. We've done something wrong. We need better documentation. We need to explain it. We need better examples. We need better next. Yes. We need to adopt the syntactic changes that have come in Python 3 that makes it easier. There's no way we can just keep going as we are and expect people to get it. So yeah, that's the angry for now. Don't think there's any more angry, so now I'm going to be happy. So, deferreds are an object which holds a result at some point in time. That point in time can be now, it can be later, it could be never. It's just at some point. So, you give it callbacks, and callbacks mean when you have a result, call the function with this result. And they have a callback chain, so you might generally have several that are passed through. So here's an example. So you make a deferred. You add one callback, which takes the result at some point in time, and it adds one to it, because the Lambda, it just returns it. So you take an input, you return an output. We add another callback, which then prints it. And we do d.callback, which kicks off the deferred chain. It gives it a value. And what we'll get is we will get 13. So it's like a production line. You have a bunch of steps that you do. You mutate the data, or you add things to it, or you throw it away. It doesn't matter. And then you have one initial result, which might be, say, a web response, and you go through and OK, so if you're using something like Scrapey, then you would get the web request, and then you'd take some things out, and then you'd load it into a database, and when that's done, you complete. So as you saw there, add callback returns a deferred. So d.add callback, it returns a deferred object. So you can chain it. So it's always the same callback. So you can chain it. So that there is equivalent. So there's some instances where you want to chain it just so that it's easy to look at. Callbacks can be synchronous, although they shouldn't block. They must not block. But they can return a deferred. So they can say, I don't have a result now, but I may have it at some later point. Many things in Twisted return deferreds. So if you have Trek, which is a Twisted sort of clone of requests, so with the same sort of API, you can see that returns a deferred because it doesn't have a result right now, because it might be taking a couple hundred milliseconds, or it might take a second, or it might just time out completely. So here is a fully fledged script using React, which starts up the Twisted reactor and sort of prepares it. So most times you only need to start the reactor once. But this is just a complete example here. So trek.get to my website, add a callback, which is trek.content, which reads the response from it and parses it, and then print it. So what we'll get is it'll print it. And I didn't show it because it's like 7,000 lines of mangled HTML because I used like Notepad to write it. And the Wi-Fi's gone again. OK. So inline callbacks. Now, who here knows how async I/O works? Well, who here has used async I/O? That's better because not many people know how it works. It's kind of witch magic. So inline callbacks makes it work similar to that. You use yield. So this is like the 3.3 one. So sort of doesn't support yield from yet. So that there, it looks like sequential code. You request equals yield trek.get, then you call trek.content with the request, and then you print the content. It's been supported in Twisted forever, more or less since generators were introduced.